So here's our first improper integral example. We have infinity at the upper limit of integration, so we're going to replace this with a limit statement. I always use b for my upper limit of integration. All right. So replace the improper integral with a limit statement. Evaluate this antiderivative as usual. So this limit, just leave things, let that simmer for a bit. What is the antiderivative of e to the negative x? This is the 1 over a rule. The antiderivative of e to the negative x is negative e to the negative x. But this is a definite integral. It's evaluated from 1 to b. So you find the antiderivative. Right, so you find the antiderivative as usual, the antiderivative of e to the negative x. If you need to, it's a u substitution. You could just say this is the 1 over a rule. But by hook or by crook, that's the antiderivative. Notice it's negative because this is negative x. All right, now what happens? Well, you work from the inside out still. Evaluate at the top minus evaluate at the bottom. So now we have a limit. Evaluate at the top minus evaluate at the bottom. This is negative e to the negative b minus negative e to the negative 1. There's enough negative signs to satisfy anybody's thirst. So now the question is, what do we have here? Let's make this look a little bit better here. Be careful because there's negative signs all over the place. Negative exponents means this expression moves to the denominator. So this is negative 1 over e to the b. Minus negative becomes plus, and this is 1 over e. So, change to a limit, find the antiderivative, evaluate at top minus bottom, upper limit minus lower limit, and then finally evaluate this limit as b goes to infinity using our rules for limits, infinity arithmetic. As b goes to infinity, e to the b goes to infinity. So this is negative 1 over infinity plus 1 over e. This is 0. In our infinity arithmetic, any finite constant divided by any non-zero constant divided by infinity is 0. So this is 0. And positive negative 0 is the same thing. So that's 1 over e, which is 1 over 2.7, which is, I don't know, a little more than 1.5 or something like that. And so that is the final result. This number, this is a number, which is that whenever you compute a definite integral, your answer is going to be the scalar with respect to the variable of this antiderivative. So that's the procedure. Change this to a limit statement, and then evaluate the antiderivative. It's a definite integral. Top minus bottom, upper limit minus lower limit. Simplify that if you need to, and then finally evaluate this limit and you're out.